All right, we're going to be looking at section 13.2, which is a review of finding the slope of a line that you learned in Algebra 1 and Algebra 2. Just to remind you guys, slope is the steepness of a line. The slope formula needs to be memorized if it's not memorized already. M stands for the modulus of slope, so M is representation for slope. M equals y2 minus y1 divided by x2 minus x1. So you're looking at the vertical change over the horizontal change between 2 points. So like you learned in science class, delta means change in. So you're looking at the change in the y's over the change in the x's. When looking at slope of a line, whenever you're dealing with a rising line, so we're going to take notes on this. A rising line always has a positive slope. Okay, something you need to know. A rising line always has a positive slope. If you're dealing with a falling line, okay, as you read the graph from left to right, if the line is falling, your slope of that line will always be a negative number. So a falling line has a negative slope. If the line is a vertical line, okay, if the line is a vertical line, the slope is undefined. Slope is undefined. In middle school, when you guys first were taught this, you might have seen your teachers make an N out of this. Okay, N stands for no slope. That's the middle school way of saying undefined slope. In high school, we're going to use our vocab word and say undefined. So again, if you have a vertical line, you can make an N out of it. N stands for no slope. Undefined means no slope. If you have a horizontal line, your slope for any horizontal line is 0. You can make a Z out of a horizontal line as a visual to memorize that any horizontal line has a 0 slope. All right, now if we're finding slope between 2 points, just like what we did with the distance formula, you're going to designate your points as x1, y1, standing for one ordered pair, and x2, y2, standing for another ordered pair. It doesn't matter how you designate these, okay? Just be consistent. So if you're going to call the first ordered pair x1, y1, then the second ordered pair is x2, y2. We're going to plug these into our slope formula and then simplify. So we have M equals the change in y, -5 minus -2, over the change in the x's, 3 minus -1. Careful with your double negatives. So we get -3 over +4. So therefore our slope is -3/4. Would your line be rising or falling? Let's look at the sign. Since it's a negative slope, the line would be a falling line when graphed. Okay, so the slope between these 2 points is -3/4. All right, next example. Designate x1, y1, and x2, y2. Plug it into our slope formula. y2 minus y1 over x2 minus x1. We get 0 over 7. Whenever 0 is over the line, the slope is 0. So what do you know about this line? Since the slope is 0, it's a horizontal line. Also, I want you guys to pay attention to the points. I didn't even need to do all of this work if I looked at these 2 points. Do you see that the y values are the same? Since the y values are the same, the equation of that line has to be y is equal to 5. If you remember from your algebra classes, whenever y is equal to a number, it forms a horizontal line. What is the slope of any horizontal line? 0. Okay, so either way you want to look at it, we still arrive at the same solution, that the slope is 0. All right, next example. I need to find the slope between these 2 points. Change in the y's over change in the x's. I go to simplify. Since 0 is under the line, the slope is undefined. It's something you want to memorize. So if 0 is over the line, the slope is 0. If 0 is under the line, it's undefined. Therefore, since the slope is undefined, I'm dealing with a vertical line. All right, again, I want to show you another way of looking at this problem. Since the x values are exactly the same, the equation of the line of these 2 points is x is equal to 2. Again, that's because the x's are exactly the same. This is the format, x equals a number, for a vertical line. What is the slope for any vertical line? Undefined. Okay, 2 different ways, arriving at the same solution. All right, the next objective for today's lesson is if I give you a slope and a point, I want you to find at least 2 other points on the line. Now remember, we learned in geometry that there's an infinite amount of points on a line. Okay, just find 2 of them. So we're going to think about our pattern here. Okay, sometimes it's helpful to draw the graph so you have a visual of what's going on. Okay, this is just one way of doing this problem. If the slope is 2/3, you're looking at the change in the y's over the change in the x's. So it's the rise over the run. If I plot 1, -2, let me get some notches on this coordinate plane. All right, so we have 1, -2. It's a positive slope, so I have a rising line. The rise is 2, so I go up 1, 2. Okay, hold that place. The run is 3. Again, it's a rising line, so I go to the right, 1, 2, 3, plot a point. This point is 4, 0. So 4, 0 is another point on the line with the given slope and this current point. Now I could go again in this direction, going up 2, right 3, up 2, right 3. I could also go down 2, back 3, 1, 2, 3. So that my point now is at -2, -4. So again, there's an infinite amount of correct answers for this because there's an infinite amount of points on a line. You just want to follow your slope starting at the given point. All right, our last objective. We're going to find an unknown coordinate given the following information. I'm telling you that the slope is 4/3, and I'm giving you 2 points, but one of the points is missing a coordinate. I need to find out what that coordinate is. So before, you knew both points, and you would find the slope. We're going to be using our slope formula, but applying a little bit more algebra with the problem. So we set up our slope formula, y2 minus y1 over x2 minus x1. M, we know, is 4/3, so I'm going to plug in 4/3 in replace of m. Okay, in the numerator, we do the change in the y's, and this one's unknown, so I'm just going to call it y. So we're going to do y minus y1, which is -5, over x2 minus x1. We're going to simplify that ratio. This becomes y plus 5 because of the double negative. Same sign, add them, keep the sign, -6. We now have a proportion to solve in order to find y, because we have a ratio equal to another ratio. So we cross multiply or use cross products to solve a proportion. So I do 4 times -6 is -24. And then 3 times the quantity y plus 5. I'm showing this step because I want to make sure I distribute the 3 to both of those terms. So I have 3y plus 15 is equal to 24. I'm going to subtract 15 from each side, get -39. Divide each side by 3, I get -13. So therefore the unknown coordinate is -13. All right, I'm going to quickly run through this problem one more time, okay? Because again, this is more algebraic than what you have been doing today. You're given a slope and 2 points. You're going to be missing either an x-coordinate or y-coordinate from the point. Just name the variable, x or y. You're going to use your slope formula, designate your unknown, and plug in the other values, x1, y1, x2, y2. Simplify your ratio, then cross multiply. Lastly, use your inverse operations to solve an equation to solve for the unknown. If you guys have any questions, shoot me an email.